Okay, Algebra 1, we're moving on now to Chapter 1.4, and that chapter talks about a few things, but we're going to focus for this lesson on solving equations that have variables in them. So let's get started. First of all, I've got to tell you some vocabulary and make sure you understand these terms. An expression. An expression is simply a collection of numbers and or variables and or operations. An operation could be plus, it could be divide, it could be multiply. You know what variables are, you know what numbers are. All of those things collected together is an expression. An equation is when you have two expressions with an equal sign between them. So let's go back to that idea of an expression. When I say it could be all of those things, it could be numbers, variables, and operations. It could just be one number, or it could just be one variable. Now, so for example, two expressions, we could be saying, for example, x equals 2. Well, x is a variable, and it's an expression. 2 is a number, and it's an expression. And x equals 2 together, those make an equation. Last vocabulary word here, an inequality. That's when you have basically the same thing as an equation, but instead of an equal sign, you have an inequality sign between them. We're going to talk more about inequalities in the next lesson, but for now, let's just focus mostly on expressions and equations. Let's look at some examples just to make sure that we're clear on this. This is an expression. Now, it could have been an expression if I just had -4. It could have been an expression if I just had 3x. But it's this collection, no matter how many different things it has in it, that's an expression. It becomes an equation when you have one of these expressions on the left, another one on the right, and an equal sign in between. And like I said before, it becomes an inequality when you change that equal sign to either a greater than sign or a less than sign. So let's look at a sample equation. To make this true, you have to be able to replace that variable, that x, with a number that works. So a solution, or let me say it the way I've typed it here, any number that makes the equation true is called a solution. So the solution is the value of x, the number that you could put in place of x to make this statement true. Now sometimes with equations that have variables, you might see the solution without any kind of special effort or any special techniques. You might look at this and know that a is 1. Maybe you did, maybe you didn't. Depends on the person. But it is true that 4 minus 1 is equal to 3. If you don't see the solution, though, the textbook's suggestion, and I think it's a good one, is to turn the equation into a question. Turn the letter x, the variable, into the phrase, what number? So it reads like this, what number plus 2 equals 6? But now it becomes a question instead of a statement. And notice I've said aloud exactly what the words say over here. So here this would be, what number minus 8 equals 2? Question mark. And that's exactly what it said. Now I'm going to have you pause and see if you can think of how you would say this one. Okay, I'm going to assume that you did that, and it's 2 times what number equals 10? How about that last one? Okay, I'm going to assume that you've paused and tried it, and it's what number divided by 3 equals 2? Okay, so here's some practice. I want you to try to fill in every empty spot. So that's an empty spot, that's an empty spot, that is, and that is. Try to fill in each of them. These ones on this side that are empty will be filled with equations, and the ones that are empty on this side will be filled with questions. So go ahead and hit the pause button. Okay, I'm going to assume that you did that, and I'm going to fill them in. Why don't you hit the pause button and read what I've written here, and if you don't have what I've written here, come in and ask me about it. Let's move on. Another way to solve for x is to get x by itself by doing something that I call undoing PEMDAS. Well, in this case, it's not x, it's t. I don't want you to get confused. We're not always going to use x in this class. We'll change the letters around. But I want t by itself. I want t equals. Well, when I say undo PEMDAS, I mean I do things in the opposite order of PEMDAS. Right now, there's only one operation. There's just this addition. So there's not a lot of PEMDAS to worry about. I'm simply going to undo it by subtracting off that 7. If I had been adding, I do the opposite. But I have to do it to both sides. An equation, we didn't say this, but an equation is a balance. The two sides are in balance with each other. If I'm going to take 7 away from this side, I have to keep it in balance by taking 7 away from that side. And now what I have, well, the 7's canceled, so I have only t left on the right, and 10 minus 7 is 3. This was probably pretty easy for you to see. Let's try it, though, with something a little more complicated. Here, I really will have to undo PEMDAS in order to solve this. I'm going to move the 14 first. Why? Because if I was doing PEMDAS, I would do it last. So I'm undoing PEMDAS. I'm unwrapping this problem. So I subtract off the 14 from both sides. When I do that, on the left I'm just left with 2y, but on the right I've now got 50 minus 14, which is 36. Well, I don't want to know what 2y is. I want to know y by itself. That means I've got to divide both sides by 2. Now on the left, I'm just going to have y, and the right, 36 divided by 2 becomes 18, and that's my answer. If you didn't do it in the order of undoing PEMDAS, you would have made a mistake. You would have divided by 2 first, and then you would have had y plus 14 equals, well, 50 divided by 2 is 25. So you would have had y plus 14 equals 25. And then you would have had to subtract the 14. 25 minus 14 is 11. And you would have said y is equal to 11, but it's not. So make sure you understand this idea of undoing PEMDAS. Let's do another one. It's your turn. Go ahead and hit the pause button and see if you can figure out what r is. Okay, I'm going to assume that you did that. I hope the first thing that you did was that you subtracted 29 from both sides. If you did that, then the left was just 3r and the right was 60. Then I hope the next thing you did was divide both sides by 3. If you did that, the left side became r and the right side became 60 divided by 3, or 20, and your answer is 20. You can always check by plugging this back in. If you put 20 in for r, you'd have 3 times 20, which is 60. 60 plus 29 really is 89. All right, here's a one that's a little more challenging. I'm going to show you how to do this. First thing I'm going to do, undoing PEMDAS, is get rid of the 9. Why? Because PEMDAS would have told me to divide before I add. Now I'm undoing PEMDAS, so I get rid of the adding before I get rid of the dividing. So I've subtracted off the 9s from both sides. Now on the left I have b over 10. On the right I got 2. Okay, now to undo dividing, I multiply. So I've got to multiply both sides by 10. Well, 10 times b over 10, those 10s, let's just show you this. Remember, I really like to cancel. Those will cancel, and I'm just left with b on the left side. I get 10 times 2 on the right, and I end up with the answer b is equal to 10 times 2, or b equals 20. Remember, if you plug this back in, you can find out that it works. 20 divided by 10 is 2. 2 plus 9 is 11. Sure enough, it worked. That's it. Here's your homework. Let me make sure that I explain this. There are 2 categories of problems on page 27. The first category, just follow the book's instructions. But the second category here, they tell you a particular way to do it. Don't worry about their instructions. Instead, use any method you want to try to solve those questions and figure out what x is or t is or whatever the letter is. That's it. I'll see you in class.